Hi everyone, this is Zhongwen. In today's video, I'm going to introduce the project proposal we're going to do for CSC8710 for this semester. As you can see from the title, we're going to do the distributed neural network cross-validation interview CUDA workflow on GPU cluster. So the teammates, including me and Ziyun Xiao. Firstly, let's review a little bit of the history on neural network. So neural network, a very old idea, which is bring up in last century. So in 1950s, John McCarthy coined the term artificial intelligence. He is also one of founding father of artificial intelligence. And also in 1958, the Frank built a prototype of neural network, which is called perception. So I hope everybody knows that. And in 1989, the key idea of deep learning neural network for computer vision has been formed. And in 1997, the fundamental algorithm of deep learning for time series, such as LSTM, was developed. And why, you may ask, neural network boomed so far in recent decades? So I think there are two main factors boom the neural network. The first one is availability of the data, because in last century, there are very limited data for neural network to run, so it becomes useless if there is no weapon, right? Looks like we have much more data nowadays because of the lower cost as well as increasing storage method. That means we are able to store as much as data we need for the neural network. And the second factor, which is exponential growth of the computing capacity. So the figure on the left shows the total amount of the calculations in petaflops every day. So you can see from 2013 AlexNet, it's about 0.001 petaflop per day. So this is a graph in logarithm, so you can think this is exponential growth along past years. And you can see from AlphaGo 0, it becomes 10,000 petaflops per day, so increasingly stochastically. So this is two factors, and we are aiming to target to run fivefold cross-validation on the binary classification problem in order to find the best architecture for training a model. So here is one example of the input data we're going to use on the left side. So you can see from this figure we have two categories, the category 0 and category 1. You can also notice that this classification is quite highly unlinear because we cannot find any traditional model can easily tell these two categories apart because it's not regular or it's highly unlinear. And which is very good for neural network to do, right? Because neural network is good at nonlinearity. And here is we're going to target 5 cross-validation on GPU cluster. So we're going to utilize a GPU, which is very popular in the deep learning right now. And also in order to pick up the best architecture from the neural network, we have 3 architectures to be optional. So we can choose from 3 architectures. This cross-validation can be parallelized. And so after the cross-validation, we are able to choose the best architecture. For example, we can have 4 layers or 10 layers or 5 layers. We want to choose the best one from them. So that is why we use a cross-validation. And you can think about the cross-validation like this. And we can separate the data into 8 parts. For every fold, we use 1 part as a testing data. And we use the other parts for the training. So it looks like in this way we have 8 different data sets. Every data set have different part as a testing data, and we have different parts as a training data. So after the 8 cross-validation, so for every architecture we will get 8 models, and we will average the loss on these 8 models. And we will compare the average loss among the 3 architectures and choose the best one. So here is the hardware we're going to utilize, and many thanks to Dr. Lu and Big Data Lab in University of Wayne State support us with this hardware, and also we are very happy to be able to use them. So basically the cluster will include two types of the SoC, which is also called a system on chip. You can see the first type is called Jetson Nano, which has 128 CUDA cores, and basically it is including GPU, and also we have quad-core ARM CPU, which has 4 GB of RAM. And another type is a little bit more powerful, which is called Jetson Xavier NX, which has 384 CUDA cores and 48 tensor cores. So you can think about the difference between the CUDA cores and tensor cores is that CUDA is maybe working on a vector at a time, but the tensor is working on a matrix at a time. So tensor is the latest introduction from NVIDIA and is more powerful than CUDA core. And this type also have 6 core CPU and also have 8 GB RAM. And here is a challenge we may face across a implementation on this project. Firstly, we have to set up proper GPU cluster environment to conduct a parallel training on new network. And also we have to dispatch the proper dataset from DataView to different nodes in the cluster in order to carry out different training and testing process. And also we want to carry out necessary message passing among the nodes. So we are going to use a CUDA-aware MPI. So while combining the MPI and CUDA, we often need to send maybe the GPU buffers instead of the host buffers. If we don't use this CUDA-aware MPI, we may need to stage the GPU buffer from the host buffer or host memory. So that means you have to send the GPU data to the host, and then you can transfer from host to another host, and then you can transfer from that host to that GPU. So this is a process of GPU to GPU communication. But if we were using the CUDA-aware MPI, maybe we're going to bypassing the host memory. We're going to send data from GPU to GPU directly. So that is CUDA-aware MPI. And here is a documentation introduce this CUDA-aware MPI. Maybe we can utilize if we need any data passing among our project. So I think that's a third challenge we're going to face. So I think that pretty much for the project proposal, and thank you so much for your time. Hope we will have a good result by the end of the semester. Thank you.